Hello everybody and welcome back to Maths Miss Buick. In this video we're focusing on the rates of change and this will be found within differential calculus. So here is the question. Air is pumped into a spherical exercise ball at a rate of 250 centimeters cubed per second. Find the rate at which the radius is increasing when the radius of the ball is 20 centimeters and give your answer in terms of pi. So before we begin the question, we have to look at some notation. So dt represents the rate, dv is volume, dr is radius, and dA is the area. There's also a format which I would recommend that you would learn off because it's really handy. So we have d by a red question mark over dt. So to find this red question mark, you look and you read your question and you say, what rate am I looking for? Because you can see it's over dt. So let's read it here. Find the rate at which the radius. And if we go to our key here, radius is dr. So this little red question mark is replaced with an r. So now we have dr over dt. So the radius over the rate is equal to, well, we know the red question mark represents the r, so this is also r. And this dt never changes. So all we have to worry about is this green, or these two green question marks, which will be the same thing. So this is your connector. And to find your connector, you say, well, what shape am I talking about? Or what are my units in my question? And we can see here it's a spherical exercise ball at a rate of 250 centimeters cubed. And cubes and spheres always represent volume. So this, of course, will be dv. So our green question mark will be dv. So let's write out the question. So we want find the rate at which the radius. So we have the rate of the radius. So dr over dt is equal to, let's write it exactly as we see it. Well, the red question mark was our dr. So dr over something by the same something, always dt. And we said the connector is found by the shape. And we're talking about a sphere, so of course that's volume, so that's dv. There we go. For me, that's probably the hardest part of the question, I would think. Next of all, you're going to label your two fractions for me. This one is always related to the time. And this one is always related to the shape. Okay, so time and shape. So we need to go and look in our question to see, can we find something that has v and t represented within it? In other words, centimeters cubed and a time unit, so whether it be seconds or minutes. So let's go back and look. We have here, it says, at a rate of 250 centimeters cubed per second. So the centimeters cubed represents the v element and the second represents the t element. So we have our v and t. So let's write down instead of dv dt 250. So now we only have to worry about the dr over dv. Well, I said to you that's always the shape. So let's do a bit of work here. So the shape we're talking about is a sphere. So if you go to your log tables, your formula for a sphere is 4 over 3 pi r cubed. Now we have to differentiate because we're in differential calculus. So we have to differentiate the formula. And when we do that, we get dv all over. Now, some people find this tricky. Well, what goes down here? Well, look to see what is your variable. I know your variable is r. Don't get fooled. Pi is a number. It's not a variable. So that's dr. So let's carry out the chain rule here. Bring your 3 forward. So 3 by 4 is 12. And 3 goes into 12 4 times. So you get 4 pi r squared. Now, we do not want dv over dr in our question. We want dr over dv. So in this case, you just flip. Now, you won't flip in every question, just sometimes you may need to flip. And just be aware that you're allowed to flip. So when you flip, you get 1 over 4 pi r squared. So let's put this 1 over 4 pi r squared into our formula here. So now we have 1 over 4 pi r squared. Okay, let's put this over 1 as well because we've got two fractions now. So we have dr over dt is equal to, okay, so top by top bottom by bottom. So we have 250 all over 4 pi r squared. Now, in the question, we're also told that the r was 20. So let's replace our r with 20. So now we have 250 all over 4 pi 20 squared. Okay, so we're nearly done. There's our 250, 4 pi. We know that 20 squared is 400. So we have 250 all over, well, 4 by 400 is 1600 pi. And if we break that down, it's 5 over 32 pi. So this is the answer. However, we need a unit. So let's go back. In our question, we wanted to find out what was the rate of the radius. So what units are radiuses measured in? Well, centimetres. So it's centimetres. And what time are we talking about in this question? Well, we're talking about seconds, weren't we? If you go back here, we can see there was seconds. So our time will stay as seconds. So we finish off the question as 5 over 32 pi centimetres per second. And there we go. And we're finished the question.